All right, all right, all right. Here we go. So today, our learning concept that we're going to be talking about today is scatter plots. And I absolutely love scatter plots because scatter plots shows if there is a relationship between two different quantities. So it's kind of like, well, it's just an important thing. And let me tell you, scatter plots are used way more than you would ever imagine. Scientists use scatter plots all the time. In fact, there's a small island off of in Alaska, and they went up and they would take a look and they would count up because they tagged all these animals, and so they would count up like how many moose and how many wolves, and they took that data over a long period of time to see if there was a correlation. And obviously, you hunters out there would know there's probably a correlation between the number of moose on an island and the number of wolves. And so what they can do is use that data, and maybe what they either need to they might have to relocate some of that wolf pack so that the moose population doesn't diminish. So scatter plots are super, super, super awesome. So the first thing that I want you guys to take a look at is this one right here is and I just randomly got these. And so I don't know what the height and what the weight of anything means, but I know we are trying to see if there's a relationship between weight and height. Now, if you look, so what happened was they went out and they gathered a whole bunch of information. All right. And so this dot right here, that's Bob. Yep, that's Bob right there. And that's Jill and Joe and Jeannie and Jeremy and Jeremiah and so all of those dots actually represent a person. Okay. Now, the next thing is this. If you notice, these dots go up in this direction. Okay, see how the majority, it kind of goes up in that direction? Okay, and I can put a line through that. So when you look at this, what we can see from this is as the weight, okay, goes up, right, increases, our height increases. Oops. So when our weight increases, our height increases, or vice versa. We probably should say, as our height increases, our weight increases, right? Now, and I know you guys, there's a lot of, some of you guys might say, well, I know this one person that's really, really, really tall and super, super, super skinny. All right, there's always exceptions to the rules, right? But typically if you are 4 feet high because you're only like 5 years old, all right, your weight is not going to be as much as a person who is 6'5", right? Okay, so that's what that means. When you have a line that goes up in this direction, all right, we talked about this. Okay, again, what kind of slope does that show? Well, it's the same idea as this. When you have, as one thing increases and the other thing increases, this is called a positive correlation. So as one thing increases, the other thing increases, it makes it a positive correlation. So there's a positive relationship between weight and height. Okay, so now if you look at this one, okay, all right, and it looks like it's weight and miles per gallon. Okay, so maybe this is what truckers use, right? So, or better yet, I know my parents drive a fifth wheel, and the more the fifth wheel weighs, the worse gas mileage they get, right? And that's what this says, right? So this says that the more weight, oh, I'm sorry. Hold on, let me erase that, okay? All right, so if you look, okay, the as weight, we'll say it this way, as weight decreases, miles per gallon increases. Okay, and so when that happens, when one thing goes up and increases and the other thing decreases, that means that there is a negative correlation. Just like we learned that when you guys have a line that goes in that direction, it's a negative slope. Well, same thing here. It's a negative correlation. So as one thing increases and the other thing decreases, that would mean that it's a negative correlation. Then finally, all right, we have cat and dog people. So remember, these are actually people. So I went out and gathered a whole bunch of data. And yes, I don't have numbers down here, but I could put numbers down here, 2, 4, 6, 8, 10. All right, and 1, 2, 3, 4, right, 5, whatever. All right, and so here's what we know. If you look at it, the dots are all over the place. All right, and what that means is like, I have a lady that owns 4 cats and 2 dogs. Okay, I also have another lady that owns 4 cats and 4 dogs. So if you look at this, there's no pattern to this, right? They're just kind of scattered everywhere. And when there's no pattern to it, that means that there's no correlation. And what that means is that it doesn't matter how many cats a person has and how many dogs a person has, they have no relationship with each other. Okay? All right, so here is another example that you guys can look at. So this would be a positive correlation. This would be a negative correlation. And when they're scattered all over the place, that's no correlation. Okay? All right, so let's actually make a scatter plot. Let's go. So to make a scatter plot, what we're going to do is I've already collected the data for you. All right, so the data is trying to see if there's a relationship between arm span of a person and height of a person. Okay, so this is person number 1. Now, before I do that, I need to set up my graph. And here's my graph. I'm going to have arm span being on the x-axis and height being on the y-axis. Well, my very first thing I have to do is I have to be able to put my intervals down here. So I go over to my arm span. My smallest arm span is 20, and my largest arm span is 80. So I know that these numbers down here have to include 20 and also 80. Okay, for height, my smallest height is 18 and my largest is 78. So I know over here has to include 18, but go up to 78. So I think what I'll do is I'm going to go by tens on both sides. So 10, 20, 30, 40, 50, 60, 70, and 80. And I'll go tens on this side. 10, 20, 30, 40, 50, 60, 70, 80. All right, now, this is the cool thing about scatter plots, is that with scatter plots, we're kind of guesstimating. So if you guys remembered when we were doing linear equations, you had to be right smack dab correct on the correct number. Well, we're going by tens here, so we're going to have to kind of guesstimate where each thing would be. Okay, so here's person number 1. Person number 1 has an arm span of 45, which is right there. So I'm going to change 45, which is right there, and a height of 50. So I'm going to go up to 50 and I'm going to put a dot right there. Okay, person number 2 has an arm span of 20 and a height of 18. So I'm going to kind of guesstimate that 18 is right about there. Next person has an arm span of 80 and a height of 78, right about there. Next person has an arm span of 25 and a height of 32. So I'll put it right there. Okay, next person is got arm span 44 and 50. Did I just do that one? 44 and 50. Look at that. That's already there. What? I did not know I just put that in there. Look at me. Oh, no, I'm sorry. That was 45 and 50. So 44 and 50 might be right about there. Okay. All right. Next, 65 and 62, right about high. And last but not least is 55 and 55. All right. So if you look at this, all right, you should be able to see that the dots are going in that direction. And since they're going in that direction, we know that this is probably, well, height is increasing and arm span is increasing. Therefore, this shows a positive correlation, which basically means as one person, or as the wider your arm span, the taller you are. So that's kind of what this represents. Okay. All right. So now let's talk about using these. All right. So now we know how to graph a scatter plot. So now let's see how we can actually use them to kind of answer questions about different things. Now, before we get started, however, I want you guys to look at this. Okay, if you see right here, I have that right there. Oops, and I just kind of totally, that's called a breakpoint. Oops. Okay, that's called a breakpoint. And the reason why they put that in there is because obviously their data was in between 80 and 96. So they didn't want to have to go by tens. They wanted to write isolated. So they skipped a whole bunch of numbers right here and then went by twos. All right, where up here, they went by 75s. So let's talk about this, what this data is. This data is talking about beach visitors, and basically what we look at right here is we can tell, since all of the numbers are going up in this direction, we know that the hotter it gets, the more people will visit the beach, because as visitors increase, that means the temperature is increasing, or probably vice versa. But what I want to do is I want to make some predictions, right? And I want to be able to find out some information that if I were to continue this, if it got to be like 100 degrees, about how many how many visitors I might have, okay? Or vice versa, it could be anything. So what I'm going to do is I'm going to put in what is called a line of best fit. So I'm going to draw a line in here that really represents all of the dots. That's what the line of best fit means. So to do that, okay, I'm going to go back, and if you look, okay, it basically goes in that area, right? So my line is I'm going to try to get my line to kind of go right through that. Okay, so there's my line. My line's going to go somewhat right through that. Okay, and that's a pretty good line of best fit. Maybe I'll cut down just a little bit, just because it's going to make what I'm going to do next easier. So that is my line of best fit. So it's a line that really does a good job of representing where those dots are going to go. And you know what? I gotta kind of fix this. I'm sorry. That's really actually not a very good line of best fit. Okay, because if you look at this, I went with this guy down here, but the majority of the dots are here. So I'm going to try it again, because that's not a good line of best fit. Okay, let's try it again. All right, so if I put my line in here, all right, I'm actually going to move my line more up that way. Okay, that's probably a better line of best fit. All right, and I could probably even move this a little bit up here like that too. Okay, so now that's a better line that distributes where the dots are going. Yes, remember I told you that sometimes you're going to have it's called an outlier, and it's a dot that really doesn't fit in with the rest of them. It's still part of the data, but what that dot right there probably means is that it was like 86 or 87 degrees, and there were only like 120 visitors at the beach. Okay. All right. So I like this line a lot better. So there's my line of best fit. Now, what I want to do is you're going to write an equation for that line of best fit. So to write an equation, all right, remember, you guys should remember how to write an equation, right? To write an equation, if we write it in slope intercept form, we need to find the slope of the line and the y-intercept. Okay, so that's what we need to find. So we'll start out with slope. Well, slope of the line, basically all I have to do is look. This dot right there is a really, really, really good intercepting point. And that dot is found at 84,225. Okay, this is actually another really, really, really good dot. And that dot is found at 86 and 300. Okay, so remember, if you're given two coordinates, how you find the slope. Remember, you subtract the y values from each other over the x values. Now, FYI, you guys, I'm just going to tell you, everybody's going to probably have a little bit different of the line of best fit, just because some people might interpret those dots in a different way. And that is okay. All right, because our slopes might be off by just a hair, not a ton, but just a hair. All right, so here we go. 300 minus 225 comes out to be 75 over 2. 75 over 2 would reduce down to, oh, what is it? You know what? My brain is really not functioning so well today. So 75 divided by, where's my division sign? That must be it, I think. All right, 2 comes out to be, okay, that's what I thought, 37.5. All right, now we all know that 37.5, what this line means is this. It's the 37.5 represents the people, the visitors, and 1 represents the temperature. So what that graph or what that slope is saying is that for every 1 degree, you're getting 37.5 more people visiting the beach. Obviously, there's no such thing as a half of a person. But again, this line of best fit is just going to kind of help us make some estimates on things. Okay, so now that we have our slope, okay, let's see if I can just get that. Okay, now that we have the slope of the line, now it's our job to find the y-intercept. Okay, now remember how to find the y-intercept if you're given 2 dots. Okay, we know the slope. So it's y equals 37.5x plus b. Okay, pick a coordinate. Doesn't matter what coordinate you pick, your choice. Well, I'm going to pick this one right here. So my y is 225 equals 37.5 times my x, which is 84, and then plus the b. Okay, and now all I have to do is solve it. So first step I'm going to do is I'm going to multiply 37.5 times 84, and it comes out to be, whooshka, 3,100. Did I do that correctly? Well, this isn't making a lot of sense right now. All right. So here we go. All right. So 37.5 times 84 comes out to be 3,100. or 3,150, sorry, plus b. So now I'm going to subtract 3,150 from both sides. Oh, geez, sorry. And so my y-intercept, those are gone. So I'm going to go 225 minus 3,150. And my y-intercept is kind of weird and wacky, but I'm going to explain to you. Could be this. So b equals, okay, a negative 2,925. Okay. So here is our equation. Our equation that we just got would be y equals 37.5x minus 2,925. Okay. Now I know you're like, that does not make sense at all, but watch. If our temperature was 100 degrees, about how many people would be visiting the beach? So what I would do is I would substitute in 1,000 or 100 for this. So it would be 100 times 37.5 equals, okay, all right, minus 2,925 and about 825 people. So if you look at this chart, 100 degrees is still way about here. So if that line keeps going up and up and up, and if we go over, that makes sense. So what we just did again is we created a line of best fit, and then we wrote an equation from that line. Okay, we're going to do another example of that. Here we go. So this problem right here looks like height and weight. Okay, looks like we have 5. This goes by 5s and this goes by 2s. And my dots, look at where my dots are all at. My dots are all kind of like that. So my very first step that I'm going to do is I'm going to draw in my line of best fit. So my line of best fit is going to go, let's see, probably right around there. That's kind of a good representation of what's happening. Okay, now my job is to pick 2 good coordinates. All right, so if you look at this, I think that's a pretty good coordinate. And that coordinate looks like it is about 2010. Oh, maybe 11. So that coordinate is 2011. Okay. And then this coordinate's pretty good. All right. This coordinate right here looks like it's probably 11.6. Okay. All right. So some pretty good coordinates right there that we can use. Hopefully when you guys do this, your coordinates will work out a lot nicer than what mine did. All right. So next step that we're going to do, because we want to write an equation. So to write an equation, remember, we're going to subtract the y values. So 6 minus 11 over 11 minus 20. 6 minus 11 is negative 5. 11 minus 20 is a negative 9. Okay, you don't want to have, you do not want to have those negatives. So a negative divided by a negative is a positive. So the slope of our line is a positive 5/9. Not super friendly, but that's okay. That's okay. Next, we're going to find the y-intercept. So we're going to use our equation, y equals mx plus b, right? So we're going to, y equals, my slope is 5/9 x plus b, and I'm going to plug in my x and my y. And I'm going to pick this one right here to do. I'll show you why. So it is, oh, that's not a super fun one. I guess it doesn't matter, does it? All right, so my y is 6, okay, 5/9 times my x, and my x is 11 over 1 plus b. And now we have to solve it. So this becomes 6 equals 55/9 plus b. All right, and I ran out of room, so just a second. Let me pull this up. Let me pull this down. All right, let me shrink it. Okay, so now we're going to subtract 55/9 from both sides. Okay, now if I were you, actually let's go back. All right, let's change 55/9 into a mixed number. So 9 goes into 55 6 times with 1 left over. So this is really, so 55/9 is really 6 1/9. Let's use that number instead. Okay, so let me rewrite this. So 6 equals 6 1/9 plus b. I'm going to subtract 6 1/9 from both sides. And look what happens. Those 6's actually cancel out, leaving me with a negative 1/9. Okay, so there's my y-intercept. So here is my equation. Y equals 5/9 x plus, or we'll go ahead and make it minus 1/9. Okay. All right. And like I said, I think the problems that you guys will see will be a lot easier to do. So let's go through what you guys are working on for today.